G'day! This video is to explain the use of first-order differential equations, DEs, in a practical, fun way, using rockets and their velocities, aiming to find the final and change in velocity. Before I go into details, I'll explain some of the terms we'll be using. Specific impulse, or ISP, is the measure of the efficiency of the rocket. Why use 3 different rockets? Why not use one with the highest ISP? ISP of a rocket or jet engine is different in the changing atmospheres. One that's better on Earth won't be quite as good in vacuum space. The VC we use in the equation comes from the ISP multiplied by gravity, seen here. Our differential equation is derived from the law of conservation and momentum. This is changing around to be in terms of mass and velocity as momentum P equals mv. Thus we have our equation mdv equals negative vc dm. This is used in each of the 3 stages of the rocket and is known as a variable separable equation, since we can separate the v's and the m's to each side of the equation. Remember, vc is a constant. And so our rocket takes off. We solve our equation by taking our values to their respective sides, taking constant Pc with the m's. The v side is integrated between velocity at beginning and velocity at end, which we're trying to find. The m is integrated between mass at beginning and at end. This is the difference of the fuel. We can solve this in terms of mass m and mass of fuel P as shown, giving us an equation V equals Vc times ln m plus p over p plus v. Popping in our values on the right, we find our final velocity at the stage v1 to equal 558.13 meters per second. One section of the rocket falls off at reaching this velocity, so our m plus p changes, our m changes, our vc changes, and we have a beginning velocity now. Going back to our dE, we integrate between these values to find new ones. The biggest plot twist being that v1 equals 558.13, not 0 this time, from our last section. So it solves similarly to before, moving v1 to the outside and finding v2 equals 1642.34 meters per second. Our final stage is as our rocket reaches the vacuum. It's solved very similar to the last section, integrating between new values of mass and velocity. But since the mass values do not change after this, we will find our final velocity from this. Using the same process before, our final velocity is 2651.41 meters per second. Thank you for listening. I hope this information has been valuable and helpful. A special thanks goes to all the team of cables used in the making of this production.
Listen, baby.